This is GST 7130, Module 10 on Cloud.js and WMD, but in this case, WMD stands for Web Modern Development. I'm your instructor, Robert Hewlett, and you can contact me via the email address below. So the learning outcomes, this is definitely not an absolute list on this on this slide, but we want to be able to explain the perspective on cloud. There's lots of ways to look at it. That's why people could be arguing over the same thing sometimes. Distinguish some concepts around cloud, infrastructure as a service, software as a service, and platform as a service. Describe the evolution of JavaScript, because how does web modern development tie into the cloud, right? Do they work together well? Do they fight? What's going on? That kind of stuff. And understand the evolution of JavaScript, which help us out. Explain the impact of Node is a big thing that happened in the industry. Compare various bundlers. These are other tools that are out there. Often some of the things we do in lab just don't get big enough for a bundler. But if you're building a big web app, something like Google Sheets or Google Docs, or you might need something to help you bundle up your code so that the browser has a chance to actually load it quickly. Define the importance of tree shaking. Explain the impact of the import statement. Describe the importance of ESBuild in that. Compare Vite and Snowpack. A couple more things is we're going to talk a lot about EastWrite technology once we get into the platform stuff. So we start to explain the perspectives on cloud. We'll get into platform as a service, and we'll start breaking down ArcGIS Online, ArcGIS Server, Portal, ArcGIS Hub, all these different products, and the different tooling inside of them that can help you create applications for your end users. Right? And again, describe a little bit about web modern development. And it'd be questionable if what's about the W. We should talk about that, right? In that. So one thing that didn't fit on this slide would have been all the different EastWrite products, like services and enterprise products that are involved in something like the portal or something like ArcGIS Online. That then gives you a platform as a service that you can use to build applications. So there is a take-home message, I guess, so that'll help us guide us through this module, this lecture and lab. Right. So the take-home message is, cloud technologies and cloud platforms are great. They are a great enabler of modern, right, web or JavaScript development. In that, really hard to build all these cool apps in the browser if we don't have some sort of data layer or something like that we can hit. So the cloud technologies definitely help us provide this sort of data services tier that the browser can take advantage of. Okay, we could separate them. Hey, they're separate. Cloud's cloud and development's development. But why? Why would we want to do that, right? So because the cloud often provides infrastructure as a service, VMs and data and stuff. We'll talk about all these terms. So the cloud often provides that at its base. It can provide more depending on what you want it to do in that. So they help mobile. Most mobile applications, let's take something, even if it's a native application as, let's take Fitbit. You get all these great graphs and all that kind of stuff. But what happens is the Fitbit app kind of talks to your device and it takes all the data, ships it off to the mothership across the web. Loads up in a bunch of data services that other parts of the app come back to draw a chart of your heart rate or what kind of steps or how active you were that day and that sort of thing, crunch all the stats off your data in that. So they definitely help mobile apps, right? They provide this sort of global data tier, like a Fitbit device doesn't know who's going to buy it, where that person's going to be on the globe. But there's this global infrastructure it can hit to store its data, analyze the data, and return you back some things that you can graph on your phone in that or check in on how you're doing It's like a dashboard. We talked about those last week. Those key performance indicators, those KPIs, basically the same thing, right? So the cloud does provide this global data tier, but you want to do something with the global data tier, and that's where the web modern development comes in. Is that most browsers can hit or make use of this global data tier and get stuff done, whether it's capturing data, analyzing data, presenting data, right? Here's one like, hey, well, mobile's mobile. Mobile's not web. Well, I mean, there's Mapbox GL, right? And that's all about drawing maps really fast on your phone using JavaScript. So, no, JavaScript's on your phone. And we're going to talk about some of this and what's going on in that. Because JavaScript today just doesn't live in a browser anymore. It's in a whole bunch of different places, right? The cloud definitely helps with web mobile, right? So if we're going to have a web mobile friendly app that is technically a web app but looks good on our phone because of a responsive design, in that becomes the whole thing. When we go into mobile, there's a whole bunch of different ways to do mobile. Yes, we can do C++ applications, and we can do Java or Kotlin applications. That's often called native development. Or we have a tool that runs inside a WebView, and it's really just a web application running on your phone in that. And if it's been designed well, then it looks okay, right? Bootstrap focuses on mobile first development, right? In that. And so therefore we're going to keep them together. We're not going to I'm not going to say they're mutually exclusive technologies because they use each other, right? In that. And there's a, sort of a symbiosis or a synergy between the technologies that when someone develops an application, especially a web mobile application or a mobile first application, you're definitely dealing with web modern development and this cloud backend that typically it does more than just data, but that's sort of the easiest thing to look. Like, where are my maps coming from? Where are my dots coming from? I just captured a dot on my phone. Where did it go? That kind of stuff. So the easy explanation is with data, but you can get the cloud to do a lot more than just store some points. So how do we get here? It's a really good question and that sort of thing. So I do this talk in other courses because there is a thing about how did we get here and that. And so sometimes it helps to have an understanding of the evolution in that. And this is a very GIS centric view, especially, and it focuses almost solely on ESRI technology. And a lot of us started out in ArcInfo, went through the ArcView, ArcMap, ArcPro, and then messed around with the JavaScript API versions 3 and 4, and then eventually doing a lot more stuff in ArcGIS Online, and then working with App Studio and Web App Builder and Experience Builder. So, it's been a wild ride. So I have a video here. You can watch it. It should be in the playlist as well. It's called the Change Arc in GIS. It has been updated a couple of times, and I might even update it again. But it wouldn't hurt to get out there and watch the video, and you'll see and you can almost see a very interesting transition that ties into some stuff last week, right? So it's this move from ad hoc to infrastructure, right? So that's data sharing level that we talked about in previous modules. There was a time when it was all ArcInfo coverages, and there's no way you're going to be able to see the data I was working on because it was on some HP Unix box in the ministry, right? And it's different now that we have products like ArcGIS Online, which with a ArcGIS server backend that has hosted feature services that are REST JSON that can actually send data directly to your browser. So things have definitely changed. Okay, many generations on the website. So the concept of doing web stuff has happened early. You'll see that in the change arc form. Yeah, we had stuff where we moved off shapefiles into ArcSDE and enterprise-enabled geodatabases and stuff like that. But you'll see a whole bunch of web stuff happening really early, right? So pre ArcMap. So in between ArcInfo and ArcMap, therefore ArcPro, there was a product called ArcView, and in early stages of ArcView is when internet map servers started happening, and there were a couple available at the time, but you'll see that in the video in that. So we've gone through many generations of having cloud-like technology. It wasn't even called cloud then. Cloud didn't come till much later. But also different tries with different technology stacks. Try it with ASP, try it with Java, try it with Java Server Faces, try it with Silverlight and Flex and Flash, and try it with a web application developer framework that was from ESRI, and then try it with this version of JavaScript, and even JavaScript alone. There's another video that you can watch. There's been so many generations of JavaScript and different ways of doing it. Right, and so we've rebuilt the stack a few times, and we're still doing it again today. And that with things like Experience Builder, truly replacing Web App Builder. That is what's happening. We're on our second generation of storybooks. We're on our third generation of dashboards. So it's been, we've been doing this for a while. There's a thing where I talk about, we solve a problem just to unsolve it later. In that, so that's a continuing cycle of life thing. Okay. So many technologies, you will see a lot of technologies get killed off, right? I call them walkers and dead walkers. And that, it still might be running, but it's a bit of a zombie because people just can't move off of it, or they've invested heavily, so they can't do a big change until they get their ROI or back in that. So lots of technologies, like I said, ASP, JSP, JSF, Flex, Silverlight, JavaScript, multi-generation on the JavaScript side. We've been taking lots of runs at this. In that, apps consuming other apps for data, right? Outright cannibalism. It's kind of interesting. You'll see that towards the end of the video. So data used to be coverages and shapefiles, tables and relational databases and stuff. And then we start to see a little bit of JSON, GeoJSON, and you will see in that thing where a web, an existing app becomes data for another app. In that, it's quite interesting. So what is this cloud thing, right? In that, so cloud, good question mark. So it's a 4-letter word plus. I know it's 5 letters, but it's 4 letters plus, in that. And so, love, hate, relationship, more 4-letter words, right, for people to argue over. So the cloud. Just so you know, everything's trade-off, right? Solves some problems, causes others. But a simple way to look at it, and this isn't too crazy, your stuff on someone else's servers, right? And that's one way to look at it, is one distinction, because there's so many paradigms, because someone might try to mix it up with Web 1.0, 2.0, 3.0, what happened to 4.0, maybe try to mix up with HTML4 versus 5 in that. When we talk cloud, it's just your stuff on someone else's servers. Because technically, you could use cloud in a way that, hey, I'm just using someone else's server. I don't want this to be shared globally. It's just for our office. And so it just happens that our server doesn't run in our building or in a room down the hall. It's out on Amazon's or Google's or IBM's or someone else's servers. So it is your stuff on someone else's servers. Some people used to call it a hard drive in the sky. Not quite, but I think it is your stuff, and maybe that is files, right? But it could be your apps, and it could be your servers, and it could be your desktops like VDI, but not running on your servers. So there is a distinction between cloud versus on-premises. So are you doing that in the cloud or on-premises, or they go on-prem? That's their fancy short way of saying premises in that. Could be files and data. That's where people usually start, right? Hey, can I get a file out there? Does that work? In that, so Google Drives is pretty good. But I've seen this. I've seen people say, "Yeah, I use Google Docs," but when you see what they're doing, all they were doing is they were actually using Google Drive to put up a Word file, and they would edit it in Word and stuff like that. I go, well, no, Google Docs is a little different than Word, right? Or that sort of thing. But that's a good place to start. Your photos. Lots of people got photos in the cloud and that sort of thing. But it could be your VMs and that sort of thing. Should be. I'll make that a small list. But VMs, virtual machines. It could be a whole OS, or maybe it's a container. Could be a Linux container, could be a Docker container. I don't want to get into big, there are some big debates out there. Containers aren't OSs. Okay, right. All the containers I deal with have an OS in it, but that's, that's another story. Uh, but is it a whole operating system that you're virtualizing? Is it just what we call it like a container? So a lot of these are called Docker containers because that's where they start. Whether they're deployed on Docker or Kubernetes or something, that's a different story. But this is but this would be like an OS with applications running on it, or an application, just one application inside a container running out there on someone else's servers, Google's, Amazon, Microsoft's, not yours. That. Some people call it serverless, and I just laugh. I said, you wouldn't, what are you talking about? There's tons of servers involved. They just happen to be someone else's in that. Or it could be just DBs. Relational database services is a term from Amazon. Google has a exact same thing. I think they call it, could be like Google SQL or something like that. But basically, hey, I don't need a whole OS, or I don't, need to spin up my own containers. Do you have an OS or a container that already has Oracle running on it, or already has Postgres certain version? And they do. What you'll find is that you usually can't get the latest in that. So if you're after the latest, you usually have to spin up your own VM. But if you go to Amazon, they're pretty good. They stay up on the Postgres side for sure. But you might be on version of 13 if you're over at Google. Doesn't mean you're not going to get to 14 eventually, but they're usually a couple of versions behind before they test everything out and make sure it works with their stuff. But like maybe you just need a database. I don't need it. I don't care if it's Windows. Like it doesn't matter to me. I need Postgres, right? And so that's almost getting like to an application level. We bust out databases because they do so much of this that it's like a separate service that they offer, a lot of the cloud providers. And so basically you get a port in the sky. 5432 is Postgres, 3306 I think is MySQL, 1521 would be the Oracle listener. Like, so the concept is I'm going to get some web address and a port number, and that will represent my database, Oracle, and that. Because when you're used to client server technology, it's really easy. You're like, hey, I just need a port number and the address of the host, and I can hit it. And we can get data moving across and saved and that sort of thing. And so could be files, could be VMs, could be, a particular database that you're using. And like I said, I bust that out because it is typically a separate side of their cloud architecture because they do so much of it, right? That they have it as a separate sort of line item or service that you can get in that. Because in the end, like if your goal is, look, I need Postgres, I could care less what the OS is, right? Then this is the perfect service for you in that. Or they might even have apps. So maybe not something as big as a database, right? Not maybe something not as big as an OS. Maybe there is an app you need to run. And then you can run that app out in the cloud instead of you having to purchase a server, install an OS, get all the client libraries for the app, stand the app up. They may have it ready to go, all prepackaged. The key way to do that is with one of the above technologies called containers. So Docker containers are used a lot to do that. You create a container, which is sort of like a shrink wrap isolated version, and you, instead of virtualizing at the OS level, you virtualize at the app level in that. But an app might be it might not be containerized. That's why I don't have it up there. But they could have apps ready to go, right? Google Slides is like an app ready to go. Google Sheets is like a spreadsheet app ready to go, and that sort of thing. And it could be at a platform level. And so then what's the difference? Like when we go, what platforms usually do is it almost acts like something like VS Code like in the cloud, where you can design, drag and drop, and build an app. Right, so there's some pre-existing configured apps for you to use, or is there a platform where I can actually design an app, change how what gets stored, or change what buttons, what widgets, what controls, web controls are used on an app. So it's usually like almost like a drag and drop environment, and then you configure the particular components to talk to each other, and from that you build an app. Dashboards are much like that when you're building them in ArcGIS Online. But if you're using Experience Builder and Web App Builder, and we'll touch on these products and you'll play with them in the lab, they basically let you build an app. So you're building an app that never existed before. You usually have a limited set of controls that you can bring on, but then it's up to you where you want to put it, how you want it configured, which controls you want to have on your app, and that sort of thing. So there's usually like we could call it a designer. I'll use a more code term, an integrated development environment, where I can build up the interface and configure it in that. And so those are some of the things, right? The list could get, because we have a big argument about data, is a map data, and I talked about the cannibalism and stuff like that, and that. But basically, how it's your stuff, and then what is your stuff on someone else's server. So I'll go through a little comparison here. Cloud versus premises or on-prem, and the items in the middle. So if we look at the first one, data access, it's wider on the cloud, and that's because it's global, and that usually we can get once it's out in the cloud, we can hit it from anywhere. That's the whole idea. Narrow on premises, usually because of security concerns and firewalls settings, right? Like when you're trying to access stuff at BCIT, sometimes you got to make sure that you have started the Aruba Networks VPN, and so that you can connect. App access, wider in the cloud, narrow on premise, same thing. If you have some server where you had that data, or you had some server where you have the app, it can be hard to get at because of firewalls and security concerns by your IT team. Authentication, it's more exact on premises. Usually you know exactly who logged in. Maybe they logged into an Active Directory, so you know exactly who that user is. What you'll find out with cloud technology, a lot of times, it's like a public user or a generic user. And so when you get some crowdsourced data, you really don't know technically who did it. It was some, unauthenticated account. And that's often why crowdsourced data via the cloud has to be vetted and stuff. Hardware risk, usually really low to none in the cloud. You're just paying for a service. The hard drive, CPUs, and motherboards is something that like Amazon, Microsoft, or Google take care of, or Oracle or someone. And that higher on you, you have to be aware of firmware updates. You have to be aware of end of life on hardware components, as well as the server itself, rack space, power failures, single fault, fault tolerance, load balancing, power outages. That's on you to handle all that. So your risk goes up. Dynamic scaling can be harder on premises. We can't do much dynamically. We usually have to shut the box down, maybe throw some RAM in it. Who knows how long that takes to come in, fire it back up. And on the cloud, I'm going to say might, not guaranteed. Depends what technology you use to build your application. Some of them are designed to scale dynamically. Just throw more servers at it and it can handle the load. Legal's interesting. Usually if it's on premises, what country is our office in? Those are the rules that apply. Once you throw your stuff out in the cloud, you're not quite sure where's that running. You may not even know where the data center is. And so different laws may apply in that. So security is often higher on premises, like I said before. Exact authentication, firewall issues, the switches and routers are locked down. Lower in the cloud because it's out there in the public domain, right? And there's lots of users using the system, and there's lots of different security levels at different parts of the stack. In that, I forget what it was. There was one thing where if two virtual machines were running on the same physical hardware, and it could be a virtual machine for company X and a virtual machine for company B. Because they have shared memories, you can kind of peek in on the memory of the other server and stuff like that. That happens in the cloud and that sort of stuff. Cost, I'm going to say it depends. Okay, so it depends on your budget structure. This would be a great exam questions, by the way. So cost will depend. I think premises sometimes works out to be cheaper because of your existing budget structure, especially in government where you have something called STOB, standard business objects, in terms of how your budget's broken up and what you're allowed to spend stuff on. Sometimes the salary for maintaining the equipment is covered by someone else's budget. So for you, it's covered. It's not a cost, so it's cheaper to do it in-house. Okay. Now, is it really cheaper overall? Who knows, right? And that sort of thing. Often cloud, if you're a small shop and you have like not too many servers to put in the cloud or not too many apps or not too many desktops, it can be cost effective for you. Okay. It also gets into if your business, instead of buying assets and having them depreciate over 5 years, you might be able to write off all the service charges at 100%, right? So, but then that gets into, well, tax write-offs and how the business operates versus STOB categories on the other side. So this is where it depends is. What I've often found, and this may sound crazy, is that the cloud doesn't scale up financially, right? There's a break point. If you got to have hundreds of servers and hundreds of desktops, right? We were looking at trying to run Arc Pro on the Microsoft Azure cloud. We couldn't even afford the test server. It was costing too much. So there's no way we could roll like 300 desktops running Pro out into the cloud, right? So it depends what you're trying to do. Trying to do GPU stuff is very expensive in the cloud. And so then on-premises might be the solution in that. So I got depends on here, but I think a generic thing would be if you're smaller and have a few number of servers, cloud can be very effective. But there is this optimal, like if you think of an optimal curve, like a normal distribution, that if you have a lot of servers that have a lot of things like they need to do, like a lot of RAM and a lot of CPU and a lot of GPU, then all of a sudden the cloud becomes just astronomically expensive. Because this is a thing to remember. Amazon, Google, and Microsoft, Oracle, and those big players, they don't lose money on the cloud. They're making a killing, right? And that's why they do it. Otherwise, they would shed the business and let someone else take care of it. They make big time money on it. So if you're a smaller shop and maybe you have tax laws that let you write it all off in that within that, say, fiscal year, it might be very cost effective for you to do cloud stuff. But there is a thing, because we've tried this at BCIT, that if we were to move all of the stuff we're doing into the cloud, we get in millions of dollars, and it's just like, okay, we don't have that money, right? We just don't have it, so we'll just have to do it on premises and that sort of thing, because we just don't have it and that sort of thing. So that's why I got depends on here. But the thing would be small, if you can write it all off, cloud works. But if you start getting big and you got to put lots of servers and lots of desktops, and those have to be high-end desktops with lots of RAM, really fast disk and GPU, whoo, not fun. Not fun when you get that bill.